three transformations we have looked at. We have looked at scaling, reflection, and reciprocal transformation of equations. Now let's look at translation transformation of equations. Let's say we have this general form of the nth degree equation having roots alpha sub I. Now we define new roots. Beta sub I is equal to alpha sub I plus h. So here we are trying to arrive at an equation, or in other words, transforming this equation into another equation whose roots are the translated versions of the roots of this equation. Then alpha sub I is equal to beta sub I minus h. Substituting into the original equation, the substitution step itself is pretty straightforward. Wherever you find x, replace it with x minus h. Now, g sub n of x, here basically we are renaming the translated equation. G sub n of x equal to f sub n of x minus h is a new polynomial. So the equation is g sub n of x equal to a sub naught plus a sub 1 times x minus h plus a sub 2 times x minus h square plus dot 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 plus a sub n x minus h to the power of n equal to 0. Now after expanding and collecting like terms, we would arrive at g sub n of x equal to capital A sub naught plus capital A sub 1 x plus a sub 2 of x square and dot 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 plus a sub n x to the power of n equal to 0. Now what does this mean? What have we done? If we expand it, a sub naught is a constant, a sub 1 times h is going to be a constant, a sub 2 times h square is going to be a constant. So we basically add up all those to get a constant. So that constant, we name it as capital A sub naught. Plus, now similarly, we look at the coefficients of x after expansion. So we have a sub 1 x plus a sub 2 x minus a sub 2 times 2x h and so on. So if we add up all those, we get the capital A sub 1 of x. So basically that's what this statement means after expanding and collecting like terms. Hence the roots of g sub n of x equal to 0 are beta sub I, which are the same as alpha sub I plus h. We have arrived at the transformed equation. Now, from a purely abstract point of view, it still doesn't hit us. So let's look at an example. We have f sub n of x is equal to 8x cubed minus 4x squared plus 6x minus 1 equal to 0, where n is equal to 3. Now let h be equal to 1 by 2. So we are basically trying to translate it by shifting the roots of the new equation. So beta is equal to alpha plus 1 by 2, which implies alpha is equal to beta minus half. Substituting x with x minus 1 by 2, we get 8 times x minus 1 by 2 cube minus 4 times x minus 1 by 2 square plus 6 times x minus half minus 1 equal to 0. Now let's expand this cubic term and the square term. We get 8 times x cube minus 3x square by 2 plus 3x by 4 minus 1 by 8 minus 4 times x square minus 2 times x times 1 by 2, which is minus x, plus 1 by 4 plus 6x minus 3 minus 1 equal to 0. It's just a question of opening up the brackets. and simplifying it. We get 8x cubed minus 16x square plus 16x minus 6 equal to 0. So that is the transformed polynomial equation. Now let's look at the graphs of these two expressions. This graph is for the expression 8x cubed minus 4x square plus 6x minus 1. And the graph of 8x cubed minus 16x square plus 16x minus 6 is this graph, red one. So as you can see that the graph has moved towards the right. So now here is the critical thing. Unlike the reciprocal transformation, translation maintains the same relationship for every point on the graph. Every point is translated horizontally by h. Consequently, the roots are also translated by h. Hence, when h is greater than 0, the graph is translated to the right. When h is less than 0, the graph is translated to the left. And if h is 0, that means what? There is no change. Because when you do x minus h and h is 0, there is no change. Now, another important point is that do not simplify this equation. You might think, okay, let me divide throughout by 2 to get 4x cubed minus 8x square plus 8x minus 3 equal to 0. But then in that case, you are introducing another transformation. So that was translation transformation of equations. That's it for now. Bye.